everybody! Today we're discussing Neanderthals, best explained by creation or evolution, and we're starting right now. Oh, live now? Oh shoot, I messed that up. Okay, hey everybody. I apologize for the delay there. I've got the election on my brain. I'm sure everybody out there is here and raring and ready for just an absolutely titillating debate to get their minds off of the current events going on out in the world right now. And that's what we're here to provide for you, because today's topic is a very niche, unique, and interesting one. So I'm here with two interlocutors who I know quite well. We'll give them a chance to introduce themselves really quickly. And just so you know the format for tonight, we've got about 12, 13-minute openers with 6-minute rebuttals, followed by a 40 to 50-minute open discussion and closers, and then, of course, rounding off with the Q&A. You're going to be tagging at Modern Day Debate with your questions, not me. So just shoot those over praise this way. And Walker and Standing, would you guys like to introduce yourselves?
Sure. Yeah, I'll go first. So my name is Walker. I run a small YouTube channel where I talk about biology-related stuff, sometimes creationism. I'm an undergraduate bio major, and as of last week, I'm also an anthropology minor. So
very cool. Awesome. All right, Standing's been around here a few times. We know Standing pretty well. Let us know the deal, Standing.
My first time on Modern Day Debate. I am really nervous, guys, so thanks for the warm welcome.
Yeah.
I'll say thanks for everybody's patience. We're not even sure what happened there over the last hour. We had some good movie talk pre-show, but now the battle begins, so we're not going to be so nice anymore, are we, Walker?
Yeah, no, the talk about Star Wars is over.
Oh, yeah.
Yeah. Star Wars talk is over. Creation versus evolution talk begins. So, yeah, I'm no stranger to this channel. I've got my own channel where I also host debates, discussions on these types of topics. So if they interest you, even though you may disagree with my position, but you just like a good debate discussion, go over there, like, and subscribe. So, yeah, I'm looking forward to this. Thank you, Walker, for doing this debate. Thank you, Erica, for moderating, and Praise, thank you for being the production manager here. So
absolutely cool. Well, then we can just hop right into it. A reminder, as Standing just said, you can find the interlocutors links in the description. So what's the thing James says? If you're like, I like this, I want more of this, then check the description. You can find both of them there. They've both got channels. Before we begin, I see that there are 34 likes and 111 individuals watching. Do James a solid if you like Modern Day Debate, and hit the like button. Tensions are already high, and I'll come after you and ask you nicely if you don't. So with that, we're going to toss it over to Walker, who is starting us off. And whenever you're ready, Walker, I'll hit the timer on your first word.
All right, sick. I have the screen shared down in the bottom, the doc or whatever.
Yes, we are awaiting your approval, Praise, please.
Thank you.
One.
All right, so good to go?
Good to go.
All right. So to start, I just wanted to pull an RJ and remind the audience that nothing either of us say tonight changes the science, the data, or the consensus. I'm not a scientist. I'm just a random dude on the internet who likes talking about this stuff, and I've never done a formal debate before in anything, so I promise you, no matter how hard I try, I'm not going to represent my sources as well as they represent themselves, right? I'll post a slideshow in the comments or something, and I encourage everyone to go read the literature for themselves. So do Neanderthals fit in better with creation or evolution? And to prove my position, I need to show that they fit with evolution and they don't fit with Young Earth Creationism. Simple enough, right? So do Neanderthals fit in with common descent? Naturally, the answer is a resounding yes. Neanderthals are a sister lineage. They nest outside of our clade. The late Stephen Jay Gould wrote in his book, Wonderful Life, that life is a copiously branching bush, continually pruned by the grim reaper of extinction and not a ladder of predictable progress. We'd expect our lineage and our classification to be fuzzy because everything else about the natural world is. Why would we be the exception? Our story, just like every other life form on Earth, is filled with twists and turns and many different paths taken along the way. As I alluded to, Neanderthals took their own evolutionary path, and they're what we'd call a sister lineage. all humans alive today are more closely related to each other than Neanderthals. Thus, we share a more recent common ancestor with each other than Neanderthals, right? There's two primary mechanisms for determining lineages, morphology, or the physical features, and genetics, which is the actual DNA, the stuff going on inside the cells. So just quickly going over morphology, here's two skulls being compared. This chart shows some of the autapomorphies of each lineage, or the specific characteristics that are unique to each lineage. I don't want to spend too much time on this because Standing and I both agree that genetics is much more objective and useful in determining relatedness. And as you can see by this phyletic tree, all humans exist as a separate, independent clade from Neanderthals, while we both share ancestry further in the past, right? I'll get more into the methods of this tree building later. It's just important to understand that your DNA objectively demonstrates inheritance because you got it from your parents, right? The same techniques that tell me apart from my cousins tell us that Neanderthals were their own unique group. So since I've shown that Neanderthals fit perfectly with an evolutionary worldview, the question becomes do they fit in with a young Earth worldview? And the answer is an equally resounding no. I intentionally left this slide blank, right? There's no biblical support for Neanderthals. Believe me, I've read Genesis and Exodus multiple times, including as prep for this debate. Anything my opponent says about isolated, genetically degenerate pre-Babel or post-Babel tribes is an ad hoc rationalization of evidence that came to light well after those books were written. Of course, this isn't the Bronze Age Hebrews' fault. They didn't know, and they had no way of knowing because they didn't coexist.
One moment, Walker. Go ahead. I've paused your time. We're getting a blank screen, Praise, over on the chat.
Oh, really?
Yes, we and not blank. When you said we had blank, I left the screen blank. I was like, oh, it's blank, and then I checked, and I was like, oh wait, it's actually blank.
Fun.
Your pause though. You are at 2 minutes and 57 seconds.
Cool.
Sorry. Praise the moment. I don't know. I checked over when Walker said I've left this slide blank. I checked back over, and yeah, and it
nice.
was just so the chat's just big chilling.
It looks like it was just blank for maybe because I'm looking at the live video now. Okay. Maybe 20 seconds or so.
Okay, cool. We got it back. I can see something going on over here.
Yeah, I don't think there was too much was missed.
Yeah.
Is it good?
I think we are good. Let me double check. I'm going to refresh once. Yeah, Creation Myths is saying that you want to go back to the phylogenetic tree.
Okay.
But it's
no biggie.
It's looking like it's blank again, Praise. Wait, now it's not. What are you guys seeing? Standing.
Looks good to me right now.
Yeah,
it looks good now, but I would also say Praise. Yeah, make sure you're checking that it doesn't go blank again, and honestly, to avoid any technical issues for 2 hours. I would say if issues continue, we should maybe just use StreamYards because if there's an OBS issue. But right now it looks good, but just observe it, make sure we're good.
Well, I checked back, so it basically stopped on this slide. Yeah. Standing's going to say that Neanderthals. Oh, should I go ahead and start, or should I just give a quick review of what I'd said?
Yeah, give a 2-3 second, or I guess 4 or 5 second review, and I'll start.
Okay. Yeah. So abridged, basically. Standing's going to say that Neanderthals are fully human, and I ask what characteristics he would use to define that, right? So we have two main criteria that show that they're a separate lineage: morphology and genetics, the physical features and the DNA, right? And then here's two skulls being compared. You can see that these were morphologically very different, but that doesn't necessarily mean they nest outside the clade. The most damning piece of evidence is their genetics, which, as you can tell, the humans share more common. The non-African and African, those represent humans. They share more recent ancestry with each other than they do with Neanderthals, which are the ones on the top. But they all share a common ancestor somewhere in the deep past, right? So Neanderthals fit into, no. And then here's the slide I left blank, so we're pretty much caught up. So yeah, this is an ad hoc rationalization because there's no evidence in the Bible of Neanderthals, right? Which is weird because we know that Neanderthals lived in the Levant, right? So if they coexisted, we think that the people would have written about them, but they didn't because the Neanderthals predated the humans in that region by a substantial margin. Okay, so secondly, as a person who cares much more about empirical data, the more important question is the biological support for this proposition. And naturally, the Young Earth worldview fails this point too. So were the Neanderthals inbred? My opponent's primary explanation for Neanderthal divergence is inbreeding and hypermutation. So let's look at those claims, right? Were Neanderthals inbred? Yeah, of course, and nobody's disputing that. The more important question is, what effect did this inbreeding have? Data shows that this inbreeding is primarily affecting Neanderthals on the familial or tribal levels. If you look at a specific group, all the individuals likely share close recent ancestry. In a previous conversation, I asked you specifically what the divergence is on opposite sides of the population. At the time, I didn't have the data, but now I do, and it confirmed my prediction. When you zoom out and you look at the Neanderthals across the population, they're about 2/3 as diverse as modern humans. Their theta value, which is the number of percent differences in the mitochondria, is 0.250%, while ours is 0.365%. That's it, right? The inbreeding created low diversity within populations, but it had little effect on the divergence of the species as a whole. So now we get to the other half of your argument. Hypermutation. Neanderthals had less genetic diversity than us, especially within family units. Hypermutation should mask the inbreeding, preventing us from showing that the group share recent ancestry. This is a failed prediction of your hypermutation idea because mutations create alleles, right? You claim that Neanderthals may have also had a broken DNA repair mechanism. Well, we have their genome. Go to NCBI and blast it. Until then, I don't know why your prediction should be taken seriously without data. I'd like to remind the audience that an argument from ignorance isn't an argument. Lastly, I have you claiming here that hypermutation would show up more strongly in non-recombining DNA. This is true. So explain why Neanderthal autosomal DNA is more divergent than the uniparentally inherited DNA. Their nuclear DNA has an estimated divergence of about 600,000 years, while their mitochondrial DNA split from ours around 400,000 years ago. So even if you don't accept the dates, the nuclear DNA is about 50% more divergent. This is, once again, a failed prediction. This hypermutation problem demonstrates the crux of why your argument fails. You still don't seem to understand the difference between diversity and divergence. I've already mentioned it, but I really want to hammer it home, right? So let's use the cheetah as an example. It's extremely inbred, and it's the only member of its genus. In other words, it demonstrates low diversity and high divergence, just like Neanderthals. I'm assuming you agree with the phylogenetic placement of cheetahs, and you wouldn't claim they're a highly inbred, hypermutating population of mountain lions. These exact same techniques show that Neanderthals are a sister lineage. If they were hypermutating, they would still nest inside the Homo sapiens clade, but they don't. And this segues to the most damning piece of evidence, right? The phylogenetics. You said that genetics matters most. So let's talk about it, right? It's just using math and simulations to build trees based on parsimony and probability. It's not the number or percent of differences. It's instead the specific differences and the identities that allow us to reconstruct these relationships. So here's just a quick example I pulled from a Y chromosomal phylogeny, right? They identified 24 biallelic SNVs, which means single nucleotide variation, for which the Neanderthal sequence shared the chimpanzee allele and differed from both AOO, which is a basal human haplogroup, and the human reference. And in contrast, the chimpanzee and the AOO sequences shared just 4 SNVs, not present in the other sequences, and the chimpanzee and human reference shared 0. And for comparison, the Neanderthals shared 77 mutations with both Homo sapiens lineages and contained 16 lineage-specific mutations. And this was out of like 144 sites, right? So this wasn't a huge study. But when you compile massive amounts of this data, you're able to reconstruct these trees and include the probabilities of each node. The asterisk denotes a 100% probability. Notice how both humans and Neanderthals are monophyletic, with probabilities of 1, and that they're sister groups also with a probability of 1. Here's another example, shows the exact same thing, except they're using bootstrap values instead of probability. It's a Bayesian thing, and I won't get into specifics, but you can basically think of it as confidence, right? So it means that as much as we can know anything, this is correct. And here's a third one, once again, shows the same thing. Notice how all 3 trees are the same. This means that Neanderthals are a separate monophyletic group, no matter which metric you use, like mitochondrial DNA, Y chromosome, nuclear DNA, it doesn't matter. They all show the same thing. In fact, the lowest value I could find gave a bootstrap value of 97, which is still very high, and that specific tree only used a single human reference genome and ran 1,000 simulations, which isn't a huge study. I challenge anybody to find a lower bootstrap value than that, and that's already pretty good. So here's my absolute favorite thing. That last paper actually provided the z-scores in the supplementary information. The z-score, the lowest z-score, or the best case scenario for you, was negative 36.63. This gave a p-value of 4 times 10 to the negative 236. This means that picking an atom, a specific atom at random from anywhere in the observable universe 3 times in a row, is about as likely as these groups not being monophyletic. Once again, this was the best case scenario. Worst case scenario was a z-score of negative 68.97. So naturally, I didn't even bother to do the math. As much as we can possibly know anything, these two groups are independent monophyletic lineages. All right, so as you likely noticed, I didn't really use any morphological or paleoarchaeological data. I don't need to. We have their DNA, and this settles it empirically. Neanderthals were a sister lineage. Now my opponent is going to bring up their humanness, and I already completely agree on that, right? Neanderthals were very human. They looked and acted very similar to us. They made art. They buried their dead. They may have even had religion. My only response to that is, well, of course, right? What else would you expect from our closest relative? Chimps are many times more removed, and they already express very human-like behavior, like, politics and tool use. Why shouldn't our closest relative be even more human-like? If you want to claim that they're fully human, I'm going to need you to define the term specifically. What morphological or genetic features define fully human? If you want to convince me that I'm wrong on this, you either have to disprove phylogenetics and debunk all of statistics in doing so, or show how your mechanism fits the data better than evolution. Inbreeding and hypermutation just doesn't cut it, and if you're going to propose a new ad hoc model, I'd love to see some math. If you don't have math, at least tell me which living human group Neanderthals are more closely related to than other human groups. Where do Neanderthals nest? If you still can't do this, you still don't have a model. And here's my reference bibliography. I cede my time to the chair.
All right, cool. That was about 11 minutes and 27 seconds. Early on in the chat, I was monitoring some of your slides right when you restarted didn't show up. If you would like,
right.
I heard the first phylogenetic tree didn't show up. That's what a couple of individuals were saying. If you want to show that really fast and speak on it for, what would that be, 43 seconds? No,
no, it's fine. I showed the exact same phylogenetic tree later. I just went into more depth with it later. It was the one that I showed that the probability of each node is 100%, essentially. So it's the same one.
Roger that. Okay, cool. Then we're going to pass it on over to Standing. Again, you've got 12, 13 minutes. So please, by all means, take your time. Ideally, we shouldn't have any technical issues. But if you do, I assure you the same courtesies will be given to you as well.
Awesome. Thank you so much. Thanks for that opening presentation. Yeah, before I start my clock here, I'll start it for a max of 13 minutes as well. If Praise or whoever can just let me know if slides aren't being shown or if there are any issues, just let me know and I can, we'll just go from there. We'll deal with it. So, okay, let's get this started. Okay, throughout history, experts have looked at Neanderthals as brutish and primitive cavemen. And I heard every word of Walker's opening statement, and it seems like his biggest issue is the nesting problem and phylogenetic. So I will deal with that in my rebuttal. This is my opening. So let me cover these important issues here. So they looked at Neanderthals through a lens that suggested they were halfway ape. Nowadays, even the evolutionary community will admit that Neanderthals are a population of people that are as close to living humans today as could be possible, that don't actually live among us today, of course. They are human in their anatomy, in their brain size, in culture, in intelligence. They are not an ape man. There is no doubt that Neanderthals are among the human family. Looking at this Neanderthal child right here, you can clearly see the humanity of the Neanderthal. Evolutionists did not predict As Walker was saying, that the biblical model didn't predict what we know about the Neanderthals. As a matter of fact, that's erroneous. It's the evolutionary model that did not predict what we know about the Neanderthal. And this reconstruction here is based on the genetic data that we currently have. So like I said, there's no doubt that Neanderthals are among the human family. The biblical model would simply suggest they are a human variant, but 100% human nonetheless. This whole primitive, brutish ape-man image is still the image of Neanderthal many people have today. But in reality, they were quite different than this perception. They were a very sophisticated people. As a matter of fact, they exhibited sophistication very much unrecognized. According to the story of human evolution, Homo neanderthalensis is our closest ancestor on the human family tree. They are said to have survived a cold glacial ecosystem. Experts in human evolution have suggested that these cold and harsh environments would have influenced the Neanderthals' physique. Their bodies were relatively short. They are described as being incredibly robust and well adapted to various environmental conditions. They are also described with broad chests, bulky torsos, and muscular limbs. The adaptations seen in Neanderthals helped to generate and retain body heat. Neanderthals had large noses and strong brow ridges. They also had large brains similar in size to modern humans. Archaeological evidence suggests that Neanderthals had a relatively sophisticated culture. This, of course, speaks to intelligence, just as creationists have always predicted that Neanderthals are fully human in every way. They also lived alongside anatomically modern humans and were even interfertile and interbred, not predicted by the evolutionists. We see Neanderthal genes in modern populations. It is 100% clear that Neanderthals were fully human and a lot like modern humans today. The evidence for gene flow between Homo sapiens and Neanderthals is compelling. We find the classic Neanderthal characteristics and features in living people today. Here we've got an article, Humans and Neanderthals Less Different Than Polar Bears and Brown Bears. Now, if we found the skull cap, say, of this boxer, let's say we discovered this as an isolated bone, it is almost certain that a paleoanthropologist would identify him as a separate species, when in fact that would be totally wrong. There have been bone pits discovered that show incredible human variation in skulls. This includes numerous features associated with Homo sapiens, erectus, heidelbergensis, and Neanderthals. Many paleoanthropologists have suggested that these are not all separate species, but represent the same interbreeding species. We have a great deal of Neanderthal genetics. Most of this DNA comes from their mitochondrial DNA. Mitochondrial DNA is a very small loop of approximately 16,000 base pairs that exists outside of the cell's nucleus. We also know that mitochondrial DNA is inherited exclusively from our mothers. This is uniparentally inherited DNA. The mitochondria from the egg remains with you, while the mitochondria and the sperm are actually ejected at the time that eggs are fertilized. The Neanderthal mitochondrial DNA is quite different than modern humans today, as Walker correctly went over in his opening statement. We have looked at hundreds of thousands of human mitochondrial DNA from today, and none are quite like Neanderthals. Walker is right about this. I've got no disagreement. We will discuss this in great detail, I am sure. I also want to point out that it was a major surprise that based on the nuclear genome of Neanderthals, once again, not predicted by the evolutionist, humans from around the world have up to 2 to 3% Neanderthal DNA outside of Africa now. These Neanderthals, these ancient people, still persist with us today in our genomes. This is rather fascinating. Many people watching this debate would be surprised to know that 2 to 3% of their genetics come from Neanderthals. Outside of Africa, over 6 billion people are over 2% Neanderthal. This stuff is fascinating. It was not predicted nor expected. That all being said, let us look at the biblical creation model of ancestry. We like the uniparentally inherited DNA compartments, such as the mitochondrial DNA and the Y chromosome. We can make very specific predictions directly from the Bible based on these DNA compartments. If the Bible's account of human origins were true, we should expect one mitochondrial DNA ancestor of all people, as well as one Y chromosomal ancestor of all people. It turns out this is exactly what we find. These expectations did not have to be true if deep time evolution were true. When we look at these DNA compartments, we can build some very telling family trees. Using the empirical method, We compare mutation rates in the present, using parents to offspring. Remarkably, when comparing mutation rates between parents and children, the mutation rate turns out to be much faster than the phylogenetic rate, which assumes ape to man evolution. 99% of Walker's opening exhibited evolution-based assumptions, which is circular in answering this question. We'll discuss that in the discussion portion. There are only a few mutations that separate any human being from the mitochondrial Eve DNA consensus sequence. We know Eve, we have her sequence. I want to point out the fact that evolutionists do not want to use the fast mutation rates because it conflicts with their deep time evolutionary story. What they want to do when it comes to mutation rates in this DNA compartment is look at the differences between humans and chimpanzees and say, oh, looks like we have been separated for X number of years, millions of years, of course, according to their model. Let's give you a solid visual on this. We're going to be talking a lot about phylogenetics tonight. This right here is human mitochondrial DNA. You'll notice the starburst pattern right off the bat. I got this photo from Dr. Robert Carter, who took this from the 1,000 Genomes Project. This is a family tree of all the mitochondrial DNA genomes in the world. And I hope everybody can notice that obvious pattern. Evolutionists typically close their eyes at this part. This pattern is exactly what we would expect with explosive growth from a single person. You can see explosive growth from a center point. This pattern is exactly what we would expect. There is history on this tree. We see geography, we can see African-specific groups, Europeans, Asians, etc. This is all very fascinating and empirical. Back to the pattern. As I was saying, this is exactly what we would expect. But look at the haplogroup here in Europe, the HVR, most common haplogroup in Europe. Notice how the branches have different lengths. Do you know what this means? These people all have a common ancestor, and yet one group in there have happened to pick up twice as many mutations as their cousins. If we can pick up more mutations in the same amount of time, this means we cannot look between humans and chimpanzees and make that assumption that Walker wants to make about when they split, or even being related, say X million years ago for the split, as they would say. This is random mutations occurring in populations over periods of time. What we see is a pattern. This is the bigger picture I want Walker to address. This pattern goes back to a center point. Mitochondrial DNA mutates fast. We are looking at one woman, recent, exactly what the Bible says, exactly what has been predicted. Mitochondrial DNA has very little variation worldwide. Humans in general have very low genetic diversity. How does my opponent Walker here explain this data? What rescue device might he invoke? The post hoc, ad hoc, out of Africa population bottleneck? We shall see. Can my opponent make testable predictions on mitochondrial DNA, phylogenetics, and mutation rates? We'll get into that into the discussion portion. Now look at this tree one more time before we move on. This is clearly a reflection of only thousands of years and not hundreds of thousands of years as proponents of human evolution would purport. There are not a lot of mutations on this tree at all. Without evolutionary-based assumptions, the clear and obvious conclusion is that this tree is young, and we've all descended from a single female ancestor who is nothing like the chimpanzee. Dr. Carter, an expert on mitochondrial DNA, does a really good job explaining that when we look at a human family tree, take two people who have the same great-great-great-grandmother, and I'm just summarizing here, of course, but let's look at their mitochondria and see how different they are. Let's have a look at how many mutations they have. It's been pointed out that on average, there is about one mutation every other generation. This means that this tree is only a few hundred generations. What a coincidence that this is exactly where the biblical Eve is. Not to mention all mitochondrial DNA is incredibly similar, nothing like the chimpanzees. We have low genetic diversity. Our Y chromosomes are geographically specific and also contain low variation with no ancient or highly mutated Y chromosomes. This is bad for ape to man evolution and the assumptions that Walker wants to make here. Evolutionists don't use measurable mutation rates. Okay, let's take the last few minutes here. I'm just at the 10-minute mark. Let's fly through some more irrefutable lines of evidence for independent origins and my position here on Neanderthals. Now, a common critic argument, though, and as we've seen here with Walker's opening, against this clear evidence for independent origins and the biblical model of ancestry has to do with the Neanderthals. I have shown clearly how Neanderthals are in every way human and have not been at all what evolutionists expect. Clearly, the data refutes universal common ancestry and ancestry with the chimpanzees. But what were the Neanderthals according to the creation model? Genetic data suggests that Neanderthals had a lot of mutations due to inbreeding and isolation. And I'll rebut his arguments on that in my rebuttal time. They were seriously inbred. They would have branched away at Babel, or possibly even before, and spread out widely. They all show serious evidence of inbreeding. This means that all the mutations that have been accumulated are manifested. Wherever there is inbreeding, we find pathology, consistent with the Babel dispersion. The hominin fossil record is simply evidence of rapid genetic degeneration, which is why we find skeletal pathology, we find reduced body size, reduced brain size. Neanderthal appears to have been just one of the few people groups that suffered from inbreeding and pathology. I look forward to Walker's arguments against why Neanderthals fit far better within the evolutionary model in light of the data that refutes the evolutionary model that assumes a human-chimpanzee split. Let me further strengthen the biblical creation model of ancestry by looking at another uniparentally inherited DNA compartment. All Y chromosomes can be traced to one single Y chromosomal ancestor. I got 1 minute here, so I'll speed through here. All male Y chromosomes on the planet are incredibly similar. There is very low variation in the Y chromosome, indicating that we came from a single ancestor in the not so distant past. Guess what? The Y chromosome has also been found to mutate fast. There's only a few mutations separating any person on the planet from the Y chromosome Adam sequence, or according to our model, of course, Y chromosome Noah. There are only about 4,500 years worth of mutations in this male specific chromosome. The only way to explain a Y chromosome that is incredibly similar worldwide, but also mutates fast and does some pretty weird things, is by the biblical creation model of ancestry. It turns out that when the chimpanzee Y chromosome was sequenced, it was discovered to be less than 70% like the human Y chromosome. Another reason why Walker here can't assume the human to chimp split in his phylogenetics. The Y chromosome is uniparentally inherited DNA. It is essentially immune to recombination. The Y chromosome should have been vastly more similar between humans and chimpanzees. And yep, I covered everything I need to, and we'll discuss everything else in the discussion portion that I look forward to. So thank you so much for listening, and thank you, Walker. Looking forward to this.
Cool. Looks like we made it through without any technical difficulties. Fingers crossed that holds for the rest of the evening.
Beautiful.
We'll be jumping right back in. First of all, these guys are easy to time keep. I don't have to do anything at all. But we'll jump right into these rebuttals. So Walker, I will set it for 6 minutes, and I'll let you know when you're at 5, and I'll start on your word.
Okay, so right off the bat, he said that according to the evolutionary model, Neanderthals are our most recent ancestor. This is not true. They're a sister lineage, as I was trying to specify in my opening. They're their own independent lineage, right? He kept saying they're fully human, as he's shown. He didn't really show any specific criteria as to why they're fully human, right? You need to point out the morphological or genetic features that would define them as fully human. And even if you want to argue that they're fully human, that they should be the same species or something, they still don't nest inside of the Homo sapiens clade. All right. You don't need chimps to be related to us for Neanderthals to be their own individual species, right? We could just have a more recent ancestor with Neanderthals, but we could, for my position to be true, for Neanderthals to be a sister lineage, all we have to do is have a common ancestor with Neanderthals. He brought up chimp Y architecture. That's not really important, but their sequence identity still aligns them with us. Oh, here's a big one. He spent a lot of time talking about phylogenetic tree, where he pulled up the mitochondrial DNA. It was an unrooted tree, which means whenever you root the tree, you're going to start seeing a nesting pattern. You're going to see cladogenesis, right? You're going to have these lines splitting into 2 branches and forming new groups. That's not what you see in the unrooted tree, because the unrooted tree just points everything to the middle. But if you use Neanderthals, the tree he used only included modern humans. If you put Neanderthals in there, there would be 2 main nodes. There would be one for modern humans and one for Neanderthals, because they're 2 independent lineages. He said that mutation rates are constant. They're not. No one's ever said that, except Jensen. Jensen used constant mutation rates to calculate the time to mitochondrial eve. He brought up pathologies. His main paper for that is Trinkhaus 2018, by the way. I reached out to Trinkhaus. He used to be a professor at my school, and he basically just blew me off. He's like, yeah, don't waste time with these guys. The paper found 66 individuals with pathologies. Only a handful were Neanderthals. Most were Homo sapiens. And it's kind of dumb to say, like, aha, these 5% of Neanderthals express pathologies, so they all express pathologies. We know that some specimens express pathologies because the majority of Neanderthals don't. And the ones that don't serve a baseline. And even then, we still have their genome. It doesn't solve their phylogenetic problem. What are some other good ones? So he said that evolution says that they're halfway ape. I mean, I think that evolution would just predict that there's sister lineages, right? There's not a march of progress as you always see on the t-shirts and stuff. There's tons of different branches going out in every direction, and Neanderthals were just a different branch from the branch that contains all living humans. Yeah, I think those are my main ones. I know he said inbreeding and hypermutating is his main thing, and I already covered that, and I'm curious to hear what his response is. Yeah, so I think that's it for me.
Cool. That was 3 minutes and 22 seconds. So we'll just toss the remaining 2 minutes, 30-ish seconds into the discussion. Standing, we will start on your word, and you have 6 minutes.
Awesome. Thanks so much, Erica. If you could just give me a 1 minute warning, we will be good. So thanks for your opening. Thanks for your opening, Walker. What I saw was standard talking points. No, it was evolutionists who did not predict what we know about the Neanderthal in terms of their humanity and their genetics. I agree with Walker. Genetics is the best way to determine ancestry. Genes and traits are what's inherited sperm and egg, not a bone, not a fossil. Morphology and anatomy can oftentimes be deceiving, as there are many instances where there is more variation within the same species than between or across species. And so I agree with Walker on that. It looks like the phylogenetics and the nesting of Neanderthals seem to be Walker's main argument and main issue, and I can answer that with ease. So let's deal with that. He also mentioned hypermutation and inbreeding, not consistent. And he claimed the autosomal DNA is also divergent in Neanderthals from humans. And he mentioned that it's about the specific differences. I agree. Evolutionary phylogenetics, though, relies on many key assumptions. That the origin of all genetic diversity is a result of mutations over time. They assume the human-chimpanzee split, which I showed there's no justification for that split in my opening. Bootstrapping assumes evolution to prove evolution. As with everything in evolution, this is circular. Bootstrapping assumes population basis, assumption-based methods. Okay, so the argument from Walker goes like this. Neanderthals exhibit a different set of biodiversity compared to Homo sapiens. And when we characterize and quantify those differences, this ends up putting Neanderthals as a sister group. You might have heard him say that, sister group, as compared to the same species as Homo sapiens. To represent the argument as accurately as possible, the argument insists that it is not about the quantity of differences, as Walker here says. I think it's important to reiterate your opponent's argument correctly. Neanderthals and Homo sapiens are 99.7% similar, but it's the specific differences. Now, we can look at specific genetic markers found in Neanderthals that are not found in any Homo sapiens, as Walker iterated. We can also look at genetic markers that are not in, or that are in Homo sapiens, but not found in Neanderthals. This indicates that Neanderthals and Homo sapiens belong to separate clades, according to Walker here, and share a common ancestor, according to the evolutionary model. And this is what I went over in my opening. One specific critic actually has made it obvious that he is relying on the Neanderthals being so different that they do not cluster with Homo sapiens when it comes to phylogenetic systematics, and it appears Walker's repeating this. So let's demolish this argument. So for many reasons, both scientific and theological, Neanderthals signify an early branch of man. And so obviously we would expect ancient man to be a lot different than modern man. Modern humans descend from only a small subset of the post-flood population. This is important. Your so-called pre-humans like Neanderthals, Denisovans, Floresiensis, Naledi, Heidelbergensis, probably early Neanderthal is what Heidelbergensis was. The less inbred version, Luzonensis, as well. We can look at ancient and modern hunter-gatherers as well. Their genomes are much different. This is true, and more diverse in many ways, as Walker iterated. There has been a lot of genes lost over time. In short, Neanderthals are more different. Why? Because they are earlier, plain and simple. This is obvious. Neanderthals especially is literally the most inbred population we have ever seen. This is empirical. And yet Walker's trying to downplay this like this is not an empirical fact. I think Walker needs to study more on this topic instead of just repeating talking points that have been debunked by myself. Dr. Carter actually points out that from Spain to Siberia, with thousands of miles in extent, we are looking at a shocking amount of inbreeding. They are unbelievably inbred. This is just a fact. Just have a look at the runs of homozygosity. They have extremely high levels of homozygosity. They have these massive stretches of identical letters in their genomes. This means there was a ton of inbreeding, and this is population-wide. Neanderthals changed over time. The classic Neanderthals we actually think of were highly inbred and on the verge of extinction. They were extremely well adapted to their cold environmental conditions. The early Neanderthals would have actually looked more similar to modern humans. Probably Heidelbergensis would have been the early Neanderthals. In other words, though, when we look at the end stage of Neanderthals, we are looking at a subpopulation of human that are extremely inbred, that have accumulated massive numbers of mutations and are on their way to extinction. Of course they would diverge. Of course they would be different. This is common sense. So in a nutshell, Neanderthals would have started off different, to answer Walker's question, which is the bulk of his argument. They would start off different, being an early branch of man. Early man would have been more diverse. The evidence suggests they picked up a ton of mutations over time. Thank you. They picked up a ton of mutations over time for a number of plausible and empirical reasons. They were also probably founded by an early patriarch in his old age. Man would have lived longer in the pre-flood world and the immediate post-flood world. And so Neanderthals would have started off with a gigantic number of new mutations and already possessed a different set of biodiversity. His other big argument in my short time here was that hypermutating and highly inbred is inconsistent, when in fact the answer to that question would have to do with the uniparentally inherited DNA, the non-recombining DNA. Hypermutation would have the largest effect on mitochondrial DNA and Y chromosome DNA. When it comes to the autosomal DNA, the biparentally inherited DNA, the increase due to hypermutation would be virtually undetectable, and for various reasons we can talk about in the discussion portion. So it is highly plausible that the biparentally inherited DNA, the nuclear DNA, would be less diverse than modern humans, and uniparentally inherited DNA would be more diverse. So that just about covers his argument, and boom, just on time. So
yeah, perfect. So we will jump right into the open discussion, and generally what the plan is to do here, just to allow and make sure that everyone gets what they want to say out without feeling like they're being gypped on time or anything like that. The way we're going to do this is we're going to go probably 3 minutes for each debater back and forth, and 3 minutes acts as a capstone, not as you have to fill 3 minutes. So hopefully that will help make sure that everybody gets in what they want to say. And so since Standing just finished that, we'll pop it over to Walker, and I'll just be keeping time. I'll let you know at 2 minutes and 30 seconds. And when you're finished, just say, and back to you or something to let the other debater know that you're finished speaking. All right. So great. On your word, Walker, we'll begin.
Oh, can I just share screen super fast again? Sorry.
Yeah, that's going to be on all praise there. You know, I'm not the person behind the screen here. All right, I'm going to start your time on your first word.
So you said that from Spain to Siberia, there was more there was less diversity in Neanderthals. They were inbred from that entire region. That's not true. Cedron and Mesmaskia is from Russia. Cedron is from Spain. They express about a little bit less diversity than humans, but not substantial. So should we just talk about that first? Should we stay on just like one topic? Just asking a quick question.
It's totally up to you guys.
Okay. Well, and I'll also just, point out again that, where is it? Their mitochondrial DNA was less divergent. Which is the exact opposite of what he said. I can find it. That's okay. But yeah, their mitochondrial DNA was less divergent than their autosomal DNA. He said that you should see hypermutation in the mitochondrial DNA. The mitochondrial DNA is how we know they were inbred. that's a contradiction.
No, I got to stop you there. No,
Okay.
inbreeding would have the biggest impact on nuclear DNA. Okay, so there's a couple things about the nuclear DNA that's important for us to understand. According to our model, the nuclear DNA of the Neanderthals would have had millions of created DNA differences. We look to created heterozygosity to explain the nuclear DNA.
Sure.
That means the corresponding increase due to hypermutation, as I was iterating, would be practically invisible to detection based on that created heterozygosity. So we know that the nuclear genome, that's where we know that the Neanderthals were highly, highly inbred. They had high levels of homozygosity, low levels of heterozygosity population-wide. I mean, would you disagree with the fact that they were highly inbred, Walker?
No, I agree with that. I just disagree that it would. You're saying that the mitochondrial DNA would not show signs of inbreeding. This paper I have right here says, in addition, the mitochondrial DNA analysis of 12 L-cedron individuals revealed low mtDNA genetic diversity and close kin relationship within the group. That's the mitochondrial DNA is how we know they were inbred. That's just a failed prediction.
Well, the mitochondrial DNA and the nuclear DNA, we can see the effects of inbreeding, right? Inbreeding reveals the hidden reservoir of genetic mistakes.
Not if they're hypermutating.
But the hypermutating would affect the mitochondrial DNA more than it would the nuclear genome, is my argument. Are you disagreeing with that?
No, I'm agreeing with that. That's just not what the data shows.
The data shows that Neanderthals were highly, highly inbred, high levels of homozygosity, and their mitochondrial DNA, for example, has a lot more mutations. It's divergent from modern Homo sapiens today. For example, and actually you can go there if you want. I want to share screen right now to go to the phylogenetic. So I'm not disagreeing that you can't see signs of inbreeding in the mitochondrial DNA. It's my position that the inbreeding, though, would have impacted the nuclear genome the most. You know, that's where we find the high levels of homozygosity. So the inbreeding and then the resulting increased levels of homozygosity, I'm saying, would be the biggest impact on the nuclear DNA. That my whole point is the argument that I've heard is that this is inconsistent. And I'm pointing out the fact that it is entirely plausible to have the biparentally inherited DNA, right, the nuclear DNA, be less diverse than modern humans, and uniparentally inherited DNA be more diverse. That's my whole argument. Go ahead, as I want to pull up the phylogenetics here.
Yeah. So, like I said, I completely agree with that. You can definitely have autosomal DNA show signs of inbreeding, and mitochondrial DNA shows signs of hypermutation. That's just not what the data shows. The mitochondrial DNA also shows signs of inbreeding. It means that they weren't hypermutating, because the hypermutation would just mask that effect. That's just how allelogenesis works, right? If you have a mutation, it creates a new allele. That's really my only response to that. It's just that's not what the data shows.
So mutations, by definition, do add genetic diversity because it's adding something that was not previously there. My whole point is you can see paper after paper that talks about the Neanderthal genome included harmful mutations that made the hominids around 40% less reproductively fit. So are you saying that there's no evidence that the Neanderthals were hypermutating, that there was evidence that they had, because I've got some quotes here. Actually, if you want to start my clock, I want to go over a couple things here. Okay. And then, so Neanderthal, the phylogenetic issue seems to be your biggest issue. So here I wanted to point out from a paper from Dr. Robert Carter. He pointed out, so he says, but small populations. So we know Neanderthals were a very small population. They're at risk due to the high rate of mutation accumulation. So right off the bat, they are already at a high risk. So I don't know how you could reject the fact that they are at least at a risk for mutation accumulation. He points out, which eventually leads to extinction due to error catastrophe. Right here, the accumulation of non-synonymous mutations in important genes is evidence for a high mutation rate, acting on a small population under threat of extinction. It could also indicate the presence of post-mortem DNA degeneration. And I take it, Praise shared my screen, that their techniques could not discern. If the results are valid, the accumulation of deleterious mutations might help to explain the disappearance of the Neanderthals. Point is, when they look at their DNA, when they look at the accumulation of non-synonymous mutations in important genes, what we're seeing is very good evidence. I mean, they're the most inbred population, not to mention the environmental factors, the epigenetic related factors. You know, what we're looking at here is strong evidence that they were hypermutating, which would explain the divergence in the phylogenetics. Not to mention genetic drift occurs more rapidly in small populations here, as we can see. You know, I'm probably almost at 3 minutes. So if you want to have a couple, I'll leave that quote up if you'd like to. I don't want to.
It was about just under 2 minutes, actually.
Oh, okay. Okay. Felt like I was talking longer. Go ahead, Walker.
I know. Yeah. It really drags when you're the one talking. You're like, oh, I don't want to go over. Sorry.
I'm just still at a point where I agree with you. Like a small inbred population should show signs of mutation, or not mutation. They should show signs of inbreeding in their autosomal DNA. Genetic drift does increase in small populations, but both of those factors work to remove diversity, not increase diversity. The inbreeding doesn't create alleles. Inbreeding helps fix alleles that were already present in the population.
Right.
You don't just have it like fast forwarding, essentially. And then, yeah. I mean, I would just say that there's no evidence of them hypermutating. The best thing that you gave was that Rob Carter said small populations usually experience higher mutation rates, not nearly high enough mutation rates to fake a 400,000 year divergence, even in your own timeline, right? If we say that they're 6,000 years old, Neanderthals diverged about twice, or not twice, but like 2/3 is back. So that would be like 10,000 years. So they have to accumulate 10,000 years of diversity or divergence, whatever you want to call it, within like 700 years. That doesn't make sense. You would think that we would see extreme levels of hypermutation between parents and offspring. We wouldn't be able to detect inbreeding at all in mitochondria. And also, you know, the higher levels of diversity still doesn't, like a hypermutation still wouldn't fix your problem with phylogenetics. It doesn't fix nesting. Like, it's the specific differences. I'm glad you pointed that out in your opening, or not your opening, your rebuttal. But it doesn't fix it. We're looking at a lineage-specific mutation. If a lineage has it, they can be included in it. Are you saying that all of these different lines individually converged on it, right? Or are you saying that humans that stayed in Babel share more recent close ancestry than they do with the Neanderthals, which would bring up your mitochondrial Eve date from like actual Eve? It doesn't. It's not quite coherent, my guy.
It's about 2 minutes.
Yeah.
Okay, awesome. Yeah, so here's the thing, though. You're missing my argument in my rebuttal. The fact that Neanderthals would have started off different, being an early branch of man. Okay, so early man themselves would have been more diverse. And then the evidence suggests that they're not only more diverse, they have more biodiversity. Now they're picking up a ton of mutations over time. That seems to actually be the case, but I want to point out patriarchal drive as well, which I think you're familiar with, where man would have lived a lot longer in the immediate post-flood world, okay, where those environmental conditions, because we know epigenetics, environment, for example, can increase mutation rates. And so the Neanderthals, if they were founded by an early biblical patriarch, right off the bat, they would have started with a gigantic number of new mutations and already possessed a different set of biodiversity. I know you don't want to admit it, but this does explain what we see in the Neanderthals, the Neanderthal genetics and the phylogenetics. I'll show that in a second, but I do want to read this because I think this really answers your question here, that we do see evidence for the hypermutation. So Dr. Carter points out, I mean, he's a mitochondrial DNA expert. He's published mitochondrial DNA data in secular journals, not just creationist journals. So he points out genetic drift occurs more rapidly in small populations. We know Neanderthals existed in small populations. According to standard population genetics theory, the likelihood of any new mutation displacing all other alleles within the population is directly proportional to the size of the population. That is, in a population of 1,000 individuals, a new mutation has a chance of 1 in 1,000 of becoming fixed. If the Neanderthal population was small or was restricted to a small size for a number of generations, and there's a paper here, Green al, they hypothesize it, genetic drift could have occurred rapidly. We would see rapid genetic drift. Now, small populations are also at a greater risk of extinction due to the high rate of mutation accumulation, which eventually leads to extinction. So, is that 2 minutes?
Just, you have till 3. I just want to make sure you
perfect. Perfect. So right here it says this Neanderthal sequence has many deleterious mutations. So they have sequences that show many deleterious mutations, several of those in one particular gene. Why is this so? Should not natural selection have weeded out these negative mutations? Instead, they accumulated. And the authors of a secular paper he's discussing here said that purifying selection had broken down. There's evidence that purifying selection broke down. This is evidence for a high mutation rate acting on a small population. I just feel like you guys are not accepting the answer. And right before so we're not assuming ape to man evolution in relationship with chimps. Therefore, you'd see on this phylogenetics, you'd see Noah, you see the African line is huge, but you still see the Africans diverging from Noah, descending from Noah, I'm sorry. And you would have the Neanderthals would go even further over here, the Neanderthal sequences. So they're even further, more mutations, hypermutation, different set of biodiversity, explains the data. Go ahead, Walker.
Wait, so you were sorry, I started choking on Propel in the middle of that. So, but you were getting on something really interesting at the end of that. You were saying the Neanderthals would be over here. I didn't see your shared screen. What line do Neanderthals nest on? Are Neanderthals in the African line, or are they in like the Asian line or middle? I don't know your model necessarily, but
are you saying my screen wasn't shared that entire time?
No, I'm sorry.
Please, when I say share screen, share the screen so my interlocutor can see.
But yeah, so where do you have the Neanderthals nesting? Because that's a very important point.
Since I was showing that, but apparently Praise doesn't know how to do his one job here. Let me share screen real quick. Okay. Like I was reading over a quote. A quote that was shared screen for Walker to see and to see the papers attached to it. So that's fine. Okay. So this is what I showed here. So this is phylogenetics, not assuming the chimp to human. Now I gave some reasons why we wouldn't assume chimp to human relationship on the mitochondrial DNA phylogenetic tree. We can go to that later, but I want to give you your time. So this would be Noah here, just assuming, okay, just taking the mitochondrial DNA as it is. We've got Noah, okay, and then we've got a larger branch of Africans, okay, but that one doesn't show Neanderthals. You'd have to go here for Neanderthals. Jensen, when he adds in the fossil sequences of Neanderthals, he says fossil DNA sequences branch off primarily sub-Saharan African lineages. So you can see here that they still nest within humans, not assuming chimp to human split, but and I'm sure you can see the screen here now. Thank you, Praise. I appreciate it. Sorry for getting mad there. I just want Walker to see the stuff I'm sharing. So you can see, as long as we see, like I pointed out, as long as the Neanderthals started off being different, being an early branch of man, and as long as we've seen mutation accumulation based on the number of factors I explained, then that just perfectly explains their divergence here. Longer lines means more mutations. So go ahead. I'll leave this on.
Okay. So that is incredibly interesting, right? Because what you have here is an unrooted phylogenetic tree. They really like the unrooted phylogenetic trees because you can put the nodes wherever you want. But if you so to test this hypothesis, you could take a sub-Saharan African person and a Neanderthal, and then use a non-African person as an outgroup, and then you should get a cladogram with the sub-Saharan person and the Neanderthal person nesting together. But they don't. The Neanderthal is still an outgroup to all living humans. It doesn't matter how many mutations they have, they don't have the lineage history that, modern Homo sapiens have. And I think that's a very important distinction to make. And you were also saying, like, the Neanderthals start off more diverse. I don't understand how they can start off more diverse when you have 10 people coming off the ark. But I would love to hear your thoughts on that.
Sure. Good question. So I want to point out that this one here is just for visual representation. This is, I believe this one's Y chromosome. Am I screen shared, Praise? So it
You
doesn't
are
look like okay, thank you. So this one's Y chromosome. I'm pretty sure. I just wanted to show you what I mean. How you can have
Is the circled one Neanderthals for reference, or is that Africans?
No. This one's Africans. Just showing you Africans also have more biodiversity, different sets of biodiversity than non-Africans. Now, this one that you said was unrooted. So the one that I showed over here,
Unrooted.
this one is unrooted because I pointed out the fact that you can see in different haplogroups, you can see people that are related. People and their cousins have happened to pick up more mutations, which actually invalidates the molecular clock that evolutionists assume for the chimp to human split, right? Look at the differences between chimp and humans. That's where they get their incredibly slow mutation rate. That's where they look to the phylogenetic rate, where a pedigree rate turns into a phylogenetic rate. But the thing is, they can't assume that based on what we know about the molecular clock, based on what we see on mutations here. But the pattern is what's important. Now, it's tough to say what the root would be. Okay, so I'm not sure. Have you read the paper? It's 20 pages. It's titled, and this is actually where you can find this tree in the 1,000 Genomes program. It's titled An Overview of the Independent Histories of the Human Y Chromosome and the Human Mitochondrial Chromosome. Have you read that one at all?
I started it, but I never finished that one. Speed sent me that one a couple days ago.
So it would take an hour to go over. I'm not going to, I've only got a couple minutes here. So the thing is, it's difficult. So the most important thing, the bigger picture, is we see a pattern. Okay. The rooting, for one, the evolutionists, where they root the tree, they're assuming the chimp to human split. Okay. That would be a circular way of doing things. Now, Jensen himself, he has rooted his tree. Okay. So this is his tree with the node. He rooted his on the L node as one of Noah's daughters-in-law. Okay, is this the appropriate rooting? He's made testable predictions as to see whether or not this rooting is appropriate, testable predictions on the history of civilization as well as mutation rates in Africans. So when we don't make those evolutionary-based assumptions with the human to chimp split, that's where we can get some nice phylogenetic trees where the pattern is exactly what we would expect, if you could still see my screen being shared. So that one is actually just false. With Jensen, he did root his tree. This one's unrooted. I prefer the unrooting one because it's tough based on what we know about patriarchal drive. We don't exactly know how related Noah's 3 daughters-in-law were. Were they sisters? It's tough to say. With patriarchal drive, you got men and women living to longer ages in the immediate post-flood world. That means Shem, Ham, and Japheth, right off the bat, would pick up a ton of new mutations that, looking at a tree, it would be tough to say, is this one generation, is this multiple generations? So I prefer the unrooting. The point is the pattern. I find nobody ever addresses the pattern, the fact that we see very few mutations. So my question to you would be, why do we see, based on let's go to the unrooted one, why do we see so few mutations? Why do we see the molecular clock has no real basis to make assumptions with ape to man evolution? And why do we see the expected pattern? Why do we see explosive growth from a center point?
Right, about 2 minutes.
Go ahead. Since I got 1 minute, I'm just going to take 10 seconds here. Let me make the question easy. Okay. There's very few mutations here. Okay. We know Eve's sequence. We know it's any two people, even your African branch, someone from Africa, they would have the most mutations, most diversity. Even they're only a few, I think maybe max 100 removed from the Eve consensus sequence. And we know mitochondrial DNA mutates fast, roughly 1 every other generation. So how do you account for that? And the Neanderthal DNA, I think the evidence does suggest that they were hypermutating. And yeah, if they were closer to the creation event, they would have had more diversity than humans today. And the bottleneck, to answer your question, it was only 1 generation followed by a rapid and exponential growth. They would have retained most of their created heterozygosity. So that's how they still have the biodiversity necessary to answer that question. So go ahead, take the full 3 minutes if you want.
So what was your specific question in there? I'm sorry if I missed that.
I wrote things down that you said, so I wanted to make sure I answered that question.
Yeah, you're good.
The question is, go ahead, Walker.
Well, I was saying your question was more or less, why do we see patterns of explosive growth?
Why do we see on this phylogenetic tree exactly what we'd expect based on the biblical model, starting from a center point, okay? and rapid and exponential growth, just like what I'm saying, based on the flood bottleneck, based on the Babel event. But most importantly, mutation rates in the mitochondrial DNA are fast. So that means there's only even accounting for substitution rates, purifying selection. What we're looking at here in this phylogenetic tree, I hope it's still screen shared. What we're looking at here is only a few mutations. How does time evolution account for such? You really have to invoke a really slow mutation rate. So that would be my question: is how do you account for what we know based on mitochondrial DNA phylogenetic trees, rooted or unrooted? Because Jensen's tree is rooted. I prefer the unrooted. Go ahead.
Well, so the specific patterning of explosive growth close to the base of a node, it just comes from the fact that most lineages die off, right? It's a form of survivorship bias in biology called the pull of the present. And also, once again, this doesn't explain the Neanderthals. You're trying to argue the out of Africa. Neanderthals completely blow out of the water, like any sort of diversity you have between Africans and humans. The regular person to the Neanderthal divergence is substantially more than the most diverse people alive. What else? Oh, molecular clocks. Yeah, they're estimates. Phylogenetic mutation rates aren't going to be constant. That's why when you see a paper, it's going to give you an error margin, right? It's going to say plus or minus 1 million years or something like that, depending on how far in the past you're going, because as you go farther in the past, there's more and more uncertainty. You're not going to find a point mutate, or like a specific point in time where they converge. Because if you do that, that's kind of dishonest. And that's what Jensen did with his mitochondrial mutation rates. He found a very specific rate from a selected study that doesn't necessarily represent the consensus, and then just made it a linear regression line, essentially, and then pointed to 6,000 years and is like, all right, here's where mitochondrial Eve is. Nobody thinks that mutation rates are constant. That's just not how biology works. Mutation rates are affected by a huge amount of factors. And even if you have a specific mutation rate between one generation to the next generation, it doesn't mean that the deep time mutation rate is going to be like that, because, like I said, most lineages die off. That's my main response there.
I appreciate those.
Seconds.
Okay, I appreciate it. I actually enjoyed that response. Lots of good things to discuss. So that's what I say. The molecular clock assumption is invalidated. That's why with these phylogenetic systematic charts that the evolutionists look to, that you're showing us here, they do assume the chimp to human split. Okay, they make those evolutionary based assumptions, and they base that off the DNA differences between humans and chimps and the time of their split. But you can't make those assumptions because the molecular clock is invalidated. That's why I pointed here. Praise, make sure I'm screen sharing so Walker can see it. The most common haplogroup in Europe here, I believe it's the most common, HVR. So when you actually look at this, notice how the branches have different lengths in here, okay? What that means, Walker, is that these people all have a common ancestor, yet one group in there have happened to pick up twice as many mutations as their cousin. So guess what? If we can pick up more mutations in the same amount of time, Walker, this means we cannot look between humans and chimpanzees and make that assumption about when they split, right? 6 million years ago, 8 million years ago, because all this is, and I pointed out, is random mutations occurring in populations over generations, over periods of time. That's why, given what we know about the molecular clock and how you can't be used to justify the human to chimp split, it's the pattern. One woman is what we see. We know mitochondrial DNA mutates fast. So what you said there about mutation rates, using the empirical method, the pedigree-based method, what we're doing is we're taking mutation rates in the present, we're using parents to offspring, okay? When we compare mutation rates between parents and children, the mutation rate turns out to be a lot faster than the phylogenetic rate. But by definition, you're right. A lot of those mutations, okay, CRISPR explains this actually quite well. A lot of those mutations are going to be weeded out over time. So by definition, the observed mutation, I think this is word for word what CRISPR said, and I liked it. He explained it well. It's true. By definition, the observed mutation rate is slower. There will be slower. The phylogenetic rate will be slower, of course, because mutations get weeded out over time. But here's the thing: that even accounts. What we see here accounts for purifying selection. It accounts for those mutations that are going to be weeded out, and still, it's perfectly in line with our model. It's only a few hundred generations. How do you get it to your date?
2 minutes and 20 seconds.
that's the problem, is how much purified selection do you have to invoke to actually get to your date? Like I said, there's only like 100 max, even with the Africans, that are separated from the Eve consensus sequence. We actually know Eve's sequence. Dr. Carter has published on it. It's fascinating. So we can tell how many mutations removed we are from the Eve sequence. And when it comes to the Neanderthals, I'm just going to fall back on the point that if they are an early branch of man, which they are, then that would indicate that they would have started off being different. Patriarchal drive as well. If they were founded by an early biblical patriarch, boom, one generation, they got a ton of mutations. Already they're going to diverge. So the African line is the longest. The Neanderthal line right here would be even longer. Of course, they were earlier, means they're different. So I think I just said my time's up. So go ahead.
Yeah. We'll pass it to Walker for his 3 minutes and just keep continuing going back and forth.
Yeah. Well, just so, as I said earlier, you don't need to use chimps to root a phylogenetic tree. It's normally what we do. It's a standard convenience in science because it's, accepted that we share a recent ancestry with chimps compared to like other organisms. But you can test your hypothesis by taking a Neanderthal sequence and a sub-Saharan sequence and using a non-African as an outgroup. And what you find is that they still don't root together. They don't nest together. That's just the phylogenetics, right? That's the math. It's the simulations. It's not just evolutionary assumptions. And I'm assuming the only real assumptions you need for phylogenetics would be like nucleotide substitution models. I know you probably wouldn't disagree with those. The organisms share ancestry, which you would agree we share ancestry with Neanderthals, and rooting. And like I said, you still don't need chimps to root the tree. You could use a different human that's a non-African to root the tree. Your null hypothesis still doesn't work, right? Or your null hypothesis is true. Your model, and also I didn't really come here to talk about biological clocks. It doesn't change the fact that you're going to have to push the date further back in time if you're using mitochondrial mutation rates, if you choose to include Neanderthals in your study. I'll cede.
Okay, all right, that was 1 minute 30 seconds.
Awesome, I appreciate that. So I would disagree. You're still assuming ape to man evolution. And here's the thing. Accounting for what we know about genetic drift, rapid genetic drift, fixation of new mutations, the biodiversity that we see, I showed you phylogenetic trees, including the Neanderthal genomes as well, looking at branching from Noah, starting with Noah, going to the Africans. You see that they're the longest lines. You can see that it's still neatly nests. It's still consistent with our model. And we're not we're not making any evolutionary based assumptions because that would be circular. And going back to what I said about the fact that on this biodiversity argument, the fact that Neanderthals, being the most inbred population we have ever seen, what that would lead to based on the environmental conditions. You can't look to today, You can't look to today and mutation or hypermutation that's going on today. We know Africans mutate differently. We know that they have more rounds of recombination. We know, and especially because historically they're at the equator, you're going to accumulate more mutations. Now, here's the thing, though. It is a fact that looking at DNA repair enzymes, a person is, and there's papers on this, they are actually going to accumulate more mutations throughout their lifetime. And the reason why is because if you have, let's say, two separate populations, and one population has a defect in their DNA repair mechanisms, let's say due to inbreeding, epigenetics, environment, Neanderthals lived in the Ice Age conditions. This is the perfect situation for hypermutation, for the gene loss, and so on and so forth. So those two populations would diverge and grow what? Further and further apart genetically. Because we know that DNA naturally breaks. It's repaired every single day, These are amazing mechanisms in our genomes. Now, based on these DNA repair mechanisms, if there's a mutation, maybe based on, like I said, a population like Neanderthals undergoing a starvation condition, then those DNA repair mechanisms would be damaged. under those stressful conditions, natural selection acts in the short term. So the body needs to survive until tomorrow. It's not focused on getting cancer 30 years down the road. So having defective DNA mechanisms, which could have been the case with Neanderthals, given what we know about their environmental conditions, that would result in what? Well, the body is shutting down things non-essential, and we are seeing more mutations accumulating from generation to generation. But the biggest thing is patriarchal drive and the fact that Neanderthals were simply an early branch of man. They would have started off different. You know, this explains the issue. So, I mean, if you want to say one last thing to that, I do want to ask you about I'm not sure how long I have. I want to ask you about the fox.
About 3 minutes.
Okay, so my question would be, and you can address any of that, I'm sure you're going to disagree with it, which is fine. Neanderthals have the same FOXP2 gene that gives modern humans the ability to speak. They discovered that some Neanderthals carried similar versions also of skin pigment genes that cause light skin and red hair, green eyes and freckles when they occur in people of European descent, when this is totally different than we see with like the chimps and your orangutans, your gorillas, your bonobos. So how do you explain that fact that it's so consistent with the FOXP2 gene? Go ahead, take your time.
Well, with regards to the FOXP2 gene, once again, they're our closest relative, right? They share a very recent ancestor with us. Of course, they're going to have the most similar proteins. And chimps do have a FOXP2 gene that's only 2 amino acids different from ours. I wouldn't want to argue that path if I were you. One, how is rooting a tree an evolutionary assumption if you're not using a chimp as the root? If you're using a human to root the tree, I don't see how that's an evolutionary assumption other than lineages diverge, which you would agree with. And then what specific DNA repair mechanism was broken? We have their mitochondrial genome. We have their entire nuclear genome with very high coverage. So which one was it, right? We know what specific genes were broken on their Y chromosome that made interfertility kind of limited. Where was it on the DNA repair mechanisms? And I'll just pose those questions, see what he responds.
Awesome. Yeah, let me, I'm going to share a screen real quick. So here's the thing. Jensen, you need to read that paper. It's 20 pages long. I just reread it last night in preparation for this. They go into, you should see what they use as an out group. They address these issues, and it still shows the basic pattern that we see in mitochondrial DNA phylogenetics and what we see with where the Neanderthals, where they branch off their DNA differences. But I want to point out the fact that, and Jensen himself, I showed an unrooted tree and a rooted tree. Jensen roots it on the L node. So people who keep saying he doesn't root his tree, it's just wrong, and I just want to point that out. So here, I'm screen sharing here. Okay, so right here. So you can look at a paper actually that shows these things. Okay, we're still learning about the Neanderthals, but Dr. Carter gives us a good reason why Neanderthals were hypermutating. So he says, Bruce Ames, a member of the prestigious U.S. National Academy of Science, so this time you should be able to see the quote, has suggested that genetic damage can be directly linked to poor nutrition. According to the theory, when under starvation conditions, the body has to decide which systems, this is kind of what I was saying earlier in my own words, but this is Carter corroborating it, based on secular papers, which will begin to shut down. This is just what happens. Now here, the evolutionist wants to say, well, where's the evidence for this? Oh, I mean, given their conditions, I mean, the evolutionists got to be so biased. I mean, given how they were the most inbred people on the planet, we know their adaptations are often due to the cold ecosystem, the cold environmental conditions. We know that there would have been a significant lack of vitamin D based on, I think he explains it here. Let me keep going before I go on another rabbit trail. According to the theory, when under starvation conditions, the body has to decide which systems to keep working and which to shut down. The genetic triage mechanism would keep an organism alive, but at the expense of less than critical cellular operations like DNA repair. This is just what happens. This is just the basic of genetics. It has been suggested by several, thank you. It has been suggested by several creationists that the Neanderthal population lived in Europe. This is corroborated by evolutionists too, under less than ideal conditions. Are people going to disagree with that? And was subjected to nutrient limitations, specifically vitamin D deficiency due to the perpetually weather during the post-flood ice age. Right here. Couple a harsh environment and poor nutrition to a small inbreeding population, and you have an instant recipe for the rapid accumulation of mutations. This is what happened. It explains the data. The FOXP2 gene, I think you missed the point. Yeah, they're only separated by a couple amino acids. Very small separation in terms of genetics, and massive difference in function, massive differences in speech and language. How can you explain that according to Neanderthals and humans, same FOXP2 gene, yet only two differences, two amino acid differences, and the chimpanzees and all your other great apes, far different in terms of function. That FOXP2 gene can be used to separate the great apes from humans. Go ahead, take your time.
So how do I explain two amino acid substitutions? The answer would just be point mutations. And once again, you didn't acknowledge the specific repair mechanism. You just said, oh, well, they had vitamin D deficiency. And I agree, they were living in crappy conditions. It was Ice Age Europe, and they were big game hunters with like spears. They would just like run at rhinos. But that still doesn't tell me which DNA repair mechanism was broken. And I'm not going to believe you until you actually start giving me specifics on this, right? Until then, it's just an argument from ignorance. It's like, well, what if this happened? I don't know. I mean, we know what specific genes were broken on the Y chromosome. We know what specific genes were broken in the nuclear DNA. Why wouldn't we know what specific DNA repair mechanism was broken in their mitochondria?
Okay, so for example, I did a quote earlier from Carter where actually, Praise, if you want to share screen again, where it showed some of these some of these non-synonymous mutations and DNA sequences in the Neanderthal genome that shows evidence for the breakdown of purifying selection and the rapid accumulation of new mutations. All it takes is one or two of those to hit the DNA repair enzymes. I want to point out the FOXP2 gene because I still don't think you understand it. The point is, you can explain it, sure, by 2 point mutations. My point is the FOXP2 gene being, and I think there's two. We have 2 FOXP2 genes, not one, and being separated by only 2 amino acid differences, yet huge difference in function. So here it says the recent DNA analysis of the Neanderthal, who according to evolutionary timescales evolved around 400,000 years ago, showed that they carried the exact same FOXP2 protein. Okay, putting them in the human category, deduced from the DNA sequence as modern humans, including the N and S at position 304 and 326, respectively. In addition to morphological and physiological evidence for the vocal tract, including the modern hyoid bone, molecular biology is now providing support that Neanderthals were fully equipped for speaking complex languages. The FOXP2 genes found in Neanderthals therefore show that they were Homo sapiens. These findings are entirely in accord with the creationist stance that Neanderthals were fully human. So that's the point, is they're only separated by a couple amino acids, yet massive, massive differences in terms of function, in terms of language, in terms of speech. And guess what? It just so happens to turn out that the Neanderthals have exactly the same FOXP2 gene as humans. So how do you account for? I'm not asking, I understand 2 point mutations. 2 point mutations is going to make that big of a drastic change in terms of function. I mean, come on, that's storyboard right there. Go ahead. Answer the question.
Well, yeah. It's not 2 point mutations. It's 2 amino acid substitutions. And yes, substituting amino acids can have huge effects on the protein. That's not, like a novel idea. Do you think that there's something like that of amino acid substitutions having a huge effect on a protein? Yeah.
No, I'm saying that they can. Oh no, I'm saying that they can have an effect, but that type of effect in terms of difference, have we ever observed that where 2 amino acid substitutions, for example, result in such a dramatic increase of function, language, speech? I mean,
okay.
Do we see that today? Is this you kind of retrofitting it to the data? Go ahead.
So in howler monkeys, actually, there's 2 opsin proteins that they produce, red and green, just like ours, but it came from a duplication event and then an unequal crossing over event, and there's only 2 amino acid substitutions there. But
you're not addressing but you're not accounting for the function, the functional difference. Yeah, we see mutations, point mutations, inversion mutations, frame shift mutations, duplicate. We see this all the time, but we don't see it result in what you apparently say 2 substitutions resulted in terms of language and speech. We don't see that, but yet the Neanderthals and humans have the exact same If you want to try again and ask the question, but I don't know if you're fully comprehending it or comprehending the fact that this FOXP2, these FOXP2 genes can be used to differentiate between humans. And, like, I can't believe that you think just 2 amino acid differences can result in dramatic differences in function, in speech, and language. I mean, if you can provide empirical data today of 2-point mutations, 2 substitutions resulting in that, then fine. But are you just retrofitting it in, or go ahead if you want to?
Well, so do you think that, like, there's something weird going on with the protein that's not in our genes? Or do you think that the protein is what controls the speech?
I'm saying that the protein, the FOXP2 genes, okay, which we know are involved in language and speech, for example, and I showed you an excerpt from a paper there at the Neanderthals and humans. I'm saying the fact that the chimpanzees and your other great apes, the fact that they are still similar in FOXP2 gene, but yet dramatic differences, kind of like the gene expression. Yeah, a lot of like similar gene sequences actually have differences in gene expression. These are types of things that we can look at to differentiate between what's related to humans and what is separated, since I'm proposing independent origins. So I think we're on the same page there with mutations. I'm just saying it's the functional difference that.
Okay.
Yeah, go ahead.
Well,
Walker,
I mean,
I'm gonna we'll go ahead and let you go, and then would it be all right? And maybe Standing says like 1 or 2 things at the end of that, but go ahead and we'll trying to move our way towards closing so we can get to the questions.
Yeah.
Is that cool, you guys?
Yeah. That's fine. We've been going for a while, so that's fine.
I'm not here to really talk about protein mechanics, but yeah, single amino acid or even double amino acid substitutions can have huge effects. There's multiple different types of amino acids that their hydrophobic and hydrophilic effects, as well as their hydrogen bonding, work together to form like secondary and tertiary structures, which result in the proteins, right? So if you put like a proline in the middle of an alpha helix, the alpha helix is going to break. If you replace a cysteine with, some other amino acid, you're not going to have the disulfide bridge. It's going to break the protein structure. So single amino acid substitutions can have these missense mutations can have a very large effect on the resulting protein. I don't quite understand why that's like controversial, I guess.
That results in such a significant difference in speech and language.
Express phenotype? Yeah.
Yeah, but we haven't seen that. We're looking at chimps. We split from the chimps, so they are our closest cousin. But yet such major differences in terms of speech, in terms of language and function, gene expression, orphan genes, Y chromosome. We can get into a number of these things. But as my last thing before the closing, I want to point out this quote. Praise, can you share my screen, brother? So this quote right here for you to see, you can look it up. Svante Pabo. I've watched a ton of lectures from him. I mean, I've watched so many lectures in the last week or so. And they all admit that there's so many questions that still need to be answered. And they always say in these lectures that the genetic data has overturned everything that they thought they knew about based on just the fossil record. Okay, they didn't predict the low genetic diversity. They didn't predict the 1Y chromosomal line, the mitochondrial DNA line. They actually have to, the evolutionists have to assume based on coalescence, random mating in order to even get that data. Random mating is not true historically, of course not. So here is a quote from Svante Pabo. I'm screen sharing here. Swedish biologist Svante Pabo made this amazing statement about Neanderthals. And he's an authority on this topic, okay? We had by now shown that there had been mixing between Neanderthals and modern humans. I knew that taxonomic wars over Neanderthal classification would continue, since there is no definition of a species perfectly describing the case. Many would say that a species is a group of organisms that can produce fertile offspring with each other and cannot do so with members of our other groups. From that perspective, we had shown that Neanderthals and modern humans were the same species, and for the number of reasons that I gave, in terms of genetics, patriarchal drive, for example, mutations in DNA repair mechanisms, the fact that they are a branch of early man, this can explain the phylogenetics and nesting argument. So I think this is just a double whammy. I mean, you have to reject the biological definition of species in order to make Neanderthalensis a separate species. And I just, I'm not ready to be on board with that. If you want, you can give him the last word on that, and then we can do quick closings.
Yeah, totally. So go ahead, Walker. And then since Walker will probably go first for closing statements, since he went first in the beginning, we'll kind of just go with 5 minutes for closing statements. So however you guys want to do that.
Wait, so are we going to closing statements now, or should I just respond?
No. Standing said you can have the last word on this, and then we'll go into closing statements. So I will, however you want to wrap up the topic, and then we'll do general closing statements.
Yeah, you can, if you want to say a few words and then boom, just go right into closing, and then I'll do a closing and we should be good.
Yeah, I mean, I'll just go into closing and I'll include that in my closing argument.
Sure.
Okay.
You 5-minute closings, I'll let you know at 4.
Sure. Yeah, that works.
Okay.
So the specific name doesn't matter, right? If you want to call Neanderthals Neanderthal or Homo sapiens Neanderthalensis, it doesn't matter. They still nest outside the clade. And secondly, there's different definitions of species. All right. So there's the biological species definition, which, talks about interbreeding and continuous populations and stuff. And then there's also the evolutionary species definition, which defines it as an organism which maintains its identity from other such lineages in space and time, and which has its fate in its own evolutionary tendencies. Yes, so Neanderthals were their own specific population, and they maintained their own lineage throughout the whole time. And then also you could even argue that they meet the biological species definition, because Y chromosome comparison has shown 3 deleterious missense mutations and 1 nonsense mutation, 2 on each lineage, by the way, that would have made hybridization probably difficult. Right? So it wasn't even total fertility, it was limited fertility. Nothing my opponent has said tonight has addressed the phylogenetics position. He has ways to test it, which I've pointed out. You could just use European as a root, and it still doesn't work. It doesn't fit his model. He likes saying that predictions are the gold standard of science, and that is patently false. The gold standard of science is accurate predictions, and none of the predictions that my opponent's model has made have been accurate. And what else would I like to say? And then I would strongly recommend you to say which specific DNA repair mechanisms were broken. I'm going to keep harping on this because, as I said in my opening, an argument from ignorance isn't an argument, right? You can't just say, oh, well, it was some DNA repair mechanism. Tell me which gene it was. Tell me where that mutation was. Tell me if it was a missense mutation, it was a frame shift mutation. Let me know what happened. I'm legitimately curious, and I don't think your model explains it. Yeah, I guess I talk fast because that's all I have.
That makes 2 of us.
All right, cool. Well, that was 2 minutes and 6 seconds. So, that's just more time to put into the Q&A. So we'll bop it over to standing, and I'll start on your first word. I'll let you know at 4.
I'm sorry, Erica. How much time do I have?
I'll let you know the second. I'll start on your first word. You got 5 minutes total, and I'll tell you where at 4 minutes.
Awesome. Okay, here. Let me share screen right now, and then you can.
I'll just start
some slides here, and I'll look at my notes, make sure I address everything. Okay, so the last thing he said that we were discussing was the FOXP2 gene. I don't think there was a good answer given. I think he might have finally understood the implications at the end, and it's actually detrimental to the discussion at hand. And from my understanding, there's actually been a study done using the FOXP2 gene, and what they did was they activated it. They gave chimps the extra gene, thinking since now they have 2, like humans, similar results might be seen. And the exact opposite happened. Mutations formed and disease occurred. There was no additional communication skills. I mean, mutations are the destroyer, not the creator. Beneficial mutations are incredibly rare. And even when they do occur, they're still reductive. And mutations are accumulating from generation to generation, most of them effectively neutral, with no type of selection to filter out those mutations. So when it comes to the Neanderthals in general, I think it's quite evident that what we're looking at are humans. I mean, is anybody going to say that if this Neanderthal child right here was standing in front of us, that they are a separate species? I mean, I'm not ready to say such a thing. And just everything that we know, he keeps saying about predictions and the testable predictions being the gold standard of science. I agree. And you can find creationists predicting that Neanderthals, when we get their genetics, would turn out to be human. And then it turned out that we interbred with them. We have their genetics, okay? And we can see here in this slide, praise, make sure you're screen sharing. Neanderthal characteristics: buried their dead, used medicine, dental hygiene, art and decoration, music. They even died for shellfish. None of these things. Actually, what's funny is they were really inventive and they had a diverse diet. One thing I want to note is that they ate tuna fish. Tuna fish is an open water fish. Neanderthals had boats. This speaks of purposeful navigation. What animal other than humans make boats and navigate the open seas? This requires a lot of intelligence, of course. They even got to some islands in the Mediterranean that were never connected to the mainland. Of course, we know they buried their dead, had music, they were into cosmetics. Now, in my notes here, I know Walker said that he agreed with all this. That's the problem. Evolutionists never assume this. You go from some ape-like brutish beast in 1856 and 2015, we got a Neanderthal child that looks exactly like, you know, a Homo sapiens child today. Now, it just comes down to this whole argument that Walker here and those that he essentially gets these talking points from, that Neanderthals exhibit this different set of biodiversity compared to Homo sapiens. And when we characterize and when we quantify those differences, what we see is Neanderthals as a sister group compared to the same species as Homo sapiens. For all these other lines of evidence, we can see they're clearly human. And for all the reasons that I provided, like Neanderthals being an early branch of man, we would expect ancient man to be a lot different than modern man, of course. Patriarchal drive, I would recommend him looking into that one. And he has to do some study on, I hopefully he finishes the paper, an overview of the independent histories of the human Y chromosome and the human mitochondrial chromosome to get some more information on that. And here's the thing, okay? We have a lot of broken genes. And every single year, we have more and more genetic related diseases being added to the genetic database. What we know about the Neanderthal conditions, what we know about how highly, highly inbred they were, this should indicate to anybody that what we'd be looking at then, especially with the nutrition deficiencies, vitamin D deficiencies, would be defects in DNA repair mechanisms. Do I know the exact gene that was involved in being broken? You know, I can't say it off the top of my head, but the data, this is what it suggests. And this is why they got to fight it tooth and nail, is for the fact that this hypermutation, or the patriarchal drive, and the fact that they're a branch of early man. Here's the thing, even recombination and gene conversion oftentimes depends, I'm going to go to some papers here, oftentimes depends on levels of heterozygosity. If early man had more levels of heterozygosity, okay, we know here PRDM9 controls activation of mammalian recombination hotspots. That would mean more diversity. That's why Africans today, they can hold more genetic diversity. And here, I love the critics' arguments with this too. And the perfect rebuttal is just read from their own secular literature right here, The Landscape of Recombination in African Americans. We have shown that PRDM9 alleles that bind a novel 17 BP motif and occur at greatly increased frequency in people of West African ancestry have led to a shift in the recombination landscape compared with people of non-African ancestry. The larger number of hotspots available to West Africans implies that at the population level, crossovers are more evenly distributed than in Europeans, and thus the shorter extent of West African LD stands for linkage disequilibrium, is not due, I want to emphasize this,
Sorry,
is not
yes,
differences.
About 5 minutes.
Okay, oh, I'm sorry, here, let me finish.
I'm sorry, Dave, you might not have heard me at 4. It was my mistake. I didn't realize I was muted. Do you want to take maybe 10, 15 seconds and say,
yes,
summarize?
Yes, 10 seconds. I'll just finish this. Is not due to differences in demographic history alone. Early man would have had more levels of heterozygosity, less mutations, and over time, what happens? Mutations destroy, not create. Okay, early man was, Neanderthals were different because they were earlier. End of story. Thank you so much.
Okay, cool. We are going to hop right into the Q&A. We'll start. We got several super chats. We got a couple of questions that weren't super chats, so we'll go ahead and prioritize the super chats first. And if we still have time, and if it's all right with the debaters, then we can get into some of the general questions, depending on how time is going. Right. So first, we'll start with, we kind of have them out of order here on the side, but that's all right. For $50 from Mr. Wilford, a question for Standing for Truth. They say, since you say we can't use molecular clocks, since the rates are not constant, how can you use the per generation pedigree rate to establish the timing of Adam and Eve? Jensen assumes constant rates, but you disagree. Please explain.
So with Jensen assuming constant rates, for example, well, he's deriving a constant rate, especially when he's looking at non-Africans. But he is saying that Africans mutate faster. He is saying that Neanderthals mutate faster. We can make predictions that if we get the genetics of Erectus or we get the genetics of Floresiensis, any of these so-called pre-humans, we're probably going to be looking at the same thing, hypermutation. So it's not all of humanity that Jensen would say is mutating at a constant rate. But here's the thing, and I won't screen share for sake of time, but that mitochondrial DNA phylogenetic tree, okay, what we're looking at is, it's true. The molecular clock, well, we know about it, okay, and I pointed to the HVR haplogroup in Europe. You can't now use the molecular clock to make assumptions about when the chimps and humans split. But here's the bigger picture. We still see very few mutations separating take any two people on this planet. Take me, take Erica, take someone over in Africa. Even though Africans have more genetic diversity, they're still only removed by a few mutations from we have the consensus sequence. I showed the paper. Definitely read it. It's very interesting. We have our sequence. We know how many mutations are removed. So yeah, the pedigree-based rate is fast. And what's funny is we emailed Parsons about all the critics, and he literally said that his work on the Parsons paper that confirmed a 6,500 year date, he said he dotted his I's and he crossed his T's, and he challenged anybody to send in their critique. I've actually got it in front of me. Send in their critique of his work, because he said if he did his work today, he'd still get the same date. So here's the thing. Evolutionists have to deal with the fast mutation rate. We've accounted for purifying selection. We've accounted for substitution rates, and still it's way too far away from the evolution date. So I hope that answered the question. Thank you so much.
All right, from David P. Neff for $5, question for Standing for Truth. How did the world population rebound so quickly after the flood to allow for Neanderthals to branch out before humans even built Babel?
Actually, good question. Very good question. So you can read about that in this 20-page paper on how many people were at the Tower of Babel. And that's the thing. There only would have been 1,000 people, 2,000 people. So that means, now I would be one of the ones to propose that Neanderthals were probably founded by an early biblical patriarch. So based on what we know about patriarchal drive, if you're living longer, you're accumulating more mutations in the reproductive cell lines. Okay, it's your germ cell lines that accumulate mutations from. Those are what's passed on. You get a ton of mutations in your somatic cell lines during your lifetime, but those aren't passed on. Your skin cells, things like this. More mutations will accumulate in your reproductive cells if you're living to 200, 300, 400 years old. So those are immediately passed on. Okay, so Shem, Ham, and Japheth, or the Neanderthal population, right away they would have started off with a different and divergent set of biodiversity. That's why you can account for those. The smaller population that you have, the more genetic drift can fixate more mutations. Now, they rebounded quickly because very limited levels of heterozygosity would have been lost at the flood, because it was just one generation followed by rapid and exponential growth. And lo and behold, this didn't have to be true. When we look at the mitochondrial DNA phylogenetic tree, that's exactly what we see, a starting point. It's like it's a starburst, and it's rapid and exponential growth, just like our model says. So that would be why it rebounded quickly. Good question.
Okay, from Mr. Wilford for $5, a compliment to Walker. Walker is thick. And that's thick with 2 C's, in case you're wondering.
I'm only worth 2 C's? Come on.
I know. No,
You're worth more than that, Walker.
Thank you.
I do want to say, Walker, this was a great debate. You did a good job with your slides, and I really enjoyed. These are my favorite debates, where you came prepared with some slides and some arguments that we could discuss. So yeah, good job.
Yeah, it was a lot of fun.
Absolutely. These are my favorite ones to moderate. I just don't have to do that much work.
I'm glad we kept it respectful for you.
Oh yeah. No, I wasn't worried with you guys. Mr. Wilford is just spending the big bucks here today. Mr. Wilford for $5 for Standing for Truth. You say bootstrapping is circular. Can you explain what bootstrapping is? Like computationally, how does that work?
Well, this seems like the type of question where we go over things like I've been in debates where we're talking about like DNA, RNA, proteins, carbohydrates, or promoter sequences. Well, can you tell me what that means? Well, bootstrapping is done with a single gene. Let's say, for sake of argument, let's make this practical. Take the CO1 gene in the mitochondria. Bootstrapping is used, and this is just an evolutionist quiz, and I guess I'll take it, but I don't always play evolutionist games. So bootstrapping is used to estimate the confidence of the branches in a phylogenetic tree. Okay. Now, bootstrap values, I like the CO1 gene. Bootstrap values are what help construct a CO1 gene a tree using DNA barcoding. Barcoding's fascinating to confirm these models. Now, bootstrap values will show nodes beyond the species level up to family, order. As a matter of fact, rarely the class from my understanding. Now, basically, though, bootstrapping values indicate how many times out of 100 the same branch was observed when repeating the phylogenetic reconstruction on a resampled set of the data. Now, bootstrap values just measure the self-consistency of data. So when you're looking, let's say, low values, that would mean that sampling different columns of the alignments give you different tree results, for example. And here's the thing: the bootstrapping, it starts off when the evolutionists are doing it. They're going to be starting like everything they do. They're starting off with assumptions. That's why with the molecular clock, they're starting off with the assumption that chimp and human split. That's circular. So, I mean, we could talk all day about bootstrapping, but I don't think anybody would disagree that it has evolution-based assumptions. You can respond to that too. I know you understand bootstrapping, Walker.
Yeah. Well, so you put in your priors to a phylogenetic study, and then you run thousands and thousands of simulations, and basically the bootstrap value is the number of times you got that specific node. And I just don't really understand. The only assumption that goes into bootstrap values is the fact that they're related, which you shouldn't disagree with within Homo sapiens or within like genus Homo in general. I thought your definition of bootstrap values was pretty decent. So there you go.
I appreciate it. Good response.
Sweet. Okay, let's see. What else do we got here? Okay, again, Mr. Wilford was spending the big money to ask Standing for Truth questions. Sorry, Standing, they're coming at you tonight. Mr. Wilford says, if Neanderthals were so inbred and their sequences so secure, why does your idol Jensen deny the validity of these sequences?
Good question. So he'll point out that, well, here's the thing. You got to read their own papers. Like I've watched so many lectures, Svante Pabo, Reich, David Reich, I think is his name. Tons of good lectures. They always started off, actually, most of the times, going over how meticulous they need to be to make sure that this ancient DNA is not contaminated. This is a real thing, because when you put DNA degrades fast. DNA is unstable, RNA is unstable. And Jensen points out, when you, even with himself working with DNA, you put it in the fridge, it still goes bad really quickly. So if it's sitting in the ground, in these bones for hundreds of thousands of years, according to the evolution model, then even the evolutionists themselves are skeptical. And I believe that the DNA, we can use it because they've resequenced it over and over again. And it also, when you do the phylogenetic analysis, it places the Neanderthals in the same group. So I think there's a bunch of reasons why we can trust it. But Jensen has his own reasons, and he had a written debate with Frello on that. So I'd recommend reading that. It's pretty good. It gets technical on all these things. I would just say the fact that the DNA is reliable, the fact that we can actually get sequences where we can look to the Neanderthal genome and compare to modern humans and do phylogenetics, is because the DNA can't be that old. If it really was hundreds of thousands of years old, it probably would be degraded to the point where it's not reliable. If it's only a few thousand years old, according to our post-Babel model, then that probably makes sense why it's reliable. So I've looked at both sides, and I would say that it is reliable. The reason why it's reliable, because it's only a few thousand years old. So.
All right, Roger that. We have an update from Mr. Wilford for $5, who says Walker's answer promotes him to fit. And this time there are 4 C's.
But then
He's kind of coming after SFT. He says SFT is only thick with 2 C's. So I really understand.
I'll be crying myself to sleep. But hey, at least we're helping James get rich tonight by
Jay, we have a lot of super chats that have kind of come in the 11th hour, which that's good. That's good. I love the questions. They're there's some good ones. For $5 from Deadly Dakota Raptor, can SFT identify the specific? I think you answered this in your conclusion, but can SFT identify the specific DNA repair mechanism mutations in Neanderthals?
Yeah, I looked in one of our books we have. It's hard to memorize all these different genes, but it looks like Neanderthals has the HYAL2 gene, yet today only 50% of East Asians have this gene. It helps the body respond better to ultraviolet radiation. There's another gene here, the TLR gene, was found to help the immune system and detect harmful bacteria, fungus, and parasites. Yet this gene is broken. It's missing in many people today too. There's another one, the POUTF3 gene. The BNC2 gene is missing in 30% of Europeans today. That's linked to freckles, lighter skin pigment. There's another one, SCN9 gene. So there's missing genes that you can find in the literature. I mean, I can't be expected to memorize every one of those genes, but they're there.
No, that's fair. Can I respond to that super fast though? First gene you talked about, you said that it's found in Neanderthals and not found in 50% of Homo sapiens, right?
Let me see here. Neanderthal has HYAL2 gene, yet today only 50% of East Asians have this gene.
Okay. And you said that gene prevents like UV damage and stuff, right? So if Neanderthals have that gene, that means they're getting less UV damage. So that's contrary to your point. That's like the opposite of what you're saying.
Well, only 50% of East Asians have this gene, and it helps the body respond better to ultraviolet radiation. I don't know. I'd have to look into
but Neanderthals have the gene.
Well, the Neanderthals were also living in a world and an environment, and being the most highly inbred population known to man, where you can't really look to today and see what's occurring. I mean, I'm just going through a list of the genes. I mean, there's a list of 100. Maybe that one helps your case a bit. I'm not too sure, but there's a lot of missing Neanderthal genes. There's a lot of defunct genes. There's a lot. So what we're seeing with the Neanderthal, what we're seeing with early man having more biodiversity versus today and a lot of gene loss, this is devolution and not evolution. So it doesn't help the evolutionist case. I don't really see how this divergence, I don't see how it helps evolution. It helps devolution, if anything, but I'll give you a list of all these genes and we'll find out which one helps with the DNA repair enzyme.
Yeah, I would love to, man. I will go through it with you.
All right. Well, let's see, from Spark 344 for $5. For Walker, please address Standing for Truth's bold as with 2 Z's. We're really going with double consonants today for emphasis. Assertions about the human population and Neanderthals, as well as biblical patriarchs.
Ooh, so I think that question is very open. I mean, I don't think the early populations would have had more genetic diversity because you're deriving all of that diversity from 10 alleles. I mean, my only problem with it really is that it's just unfounded genealogies. But at the same time, I don't really care that much. Like, if you want to find a genealogy that fits the Bible and the data, that's fine. His genealogy doesn't really fit the data; it just fits the Bible. That's pretty much it.
I guess if I could respond to that really quick. So no problem. And I appreciate the answer there. So with the created heterozygosity model, though, we need to point out, and I think this comes down to that TMR4A where you pointed out the 10 alleles. And here's the issue, though, is when we assume that the Adam and Eve model that assumes front-loaded genetic diversity, when we're looking at that TMR4A analysis or the TMR10A, 10 alleles after the flood, the point, according to our model of created heterozygosity, where we would actually have 2 lineages, where 2 lineages could be present in, say, Adam, this would be in a heterozygous state according to our model. And then also 2 in Eve, also in a heterozygous state. But based on what we know about the definition of allele, the position definition of allele, which I think you would agree with, this means let me put it this way. If we think about a single letter in the genome, then what we would be looking at is obviously 4 alleles, okay? But when we actually consider the entire gene, now we're looking at many numbers of alleles. And by definition, a gene has many positions. And if you actually look at this at the entire genome, you're looking at millions and millions of alleles. So doing this so-called TMR 10A analysis, our model would suggest that you would be looking at millions of lineages in Adam, millions in Eve, or millions in Noah. So that's why it fails. I mean, you're looking at millions of alleles in the genome. By definition, there's more than one position, of course, in a gene. So I just wanted to point that out in the fact that there'd be a lot of heterozygosity even after the flood, like a lot.
All right. Okay. Next question is going to be from Spark 344 for 10 euros. I almost said pounds, for 10 euros. They're coming for you a little on this one, SFD.
It's been fun.
You always get a lot of attention, and some of it is positive, some of it is negative. Such is the life of a prominent debater. SFT, this has been a rough week for you. First being covered on someone's channel, and once again tonight. Why do you not listen to people who are actually qualified?
Well, man, I'm really not getting any sleep tonight. So
I know.
I heard that there is this this popular YouTuber named Gutsy Gibbon. I haven't looked into her yet. I hear she makes some pretty good videos, good editing skills. Putting out videos against me. I don't know. When I find time, I'll have a look.
Listen,
have you heard of this Gutsy Gibbon?
Yeah, whoever that person is, well, I'm sure that they've got lots of memes. I'm sure they're a meme queen, some would say. I'm sure that's the main positive of that kind of content.
Hey, I've got a good sense of humor. Good super chat.
Sure. From David P. Neff for you guys are putting me in a bad position. I am a perfectly unbiased moderator. I almost didn't.
Very good modding skills today.
For Standing for Truth from David P. Neff. And I think this is our last super chat. I'm gonna double check while we're while you answer this one.
Mr. Wolford's in another.
Oh well, of course, yeah, of course.
Of course, gotta get some super chats for Walker here.
Yeah, I feel lonely.
Listen, I cannot
give James more money for me this time.
Yeah,
next time we're debating on my channel, they're gonna be coming at you that time.
Hey, listen, I cannot control the speed at which the super chats arrive. From David P. Neff for $2, how many years after the flood was Babel for Standing for Truth?
Good question. So that goes back to these papers that I've recommended as well, where they show, they got the numbers, they show the population growth rate, for example, and probably about 500 years after, 400 or 500 years after, you'd have to look at those papers. And I know, and I appreciate the one that Walker's looking at right now, the 20-page one. I'd love him to read over Dr. Carter's logic behind the rooting versus the unrooting, and we could always just have a casual discussion on that afterwards. But yeah, 400 or 500 years maybe. I'd recommend him read those papers in case I'm slightly off on that one though. All
right, roger that. And for our last super chat, for Mr. Wolford is taking the Stupid Horror Energies role tonight. And
no, wait, that is Stupid Horror Energy, probably.
Hey, listen, Stupid Horror Energy. She's definitely operating. She's operating the deep state sock account on Modern Day Debate. For $5, question for. This isn't addressed to anyone, so either of you can comment on this if you like. I have a feeling this is for Standing, just knowing the history a bit.
Probably.
Swamidass actually concedes the most recent for allele argument actually takes millions of designed alleles into account. These aren't made by mutation. Explain, please, dude.
Okay, so I'm guessing that's for me.
That's what I.
Yeah, no problems. So this one's a pretty technical one. Let me explain it to the audience. So I like to reiterate the argument as best I can. So this TMR4A, all it stands for is time to most recent for what? For alleles, okay? So this analysis, what it does is it traces the origin of our autosomal DNA differences back in time. And also, though, this is important, okay, because it comes down to recombination. This analysis actually incorporates both recombination and mutation. So the researcher can then follow lineages to the point where this TMR4A point is where 4 lineages are present in the human population. But this is why I pointed out that this model only pretends to assume the created heterozygosity model, because our model treats millions of DNA variants as the result of de novo creation. That means, given the position definition of allele, you're looking at millions and millions of alleles in the created heterozygosity model. So if I were to just accept the terms used in this TMR4A analysis, let me just accept it, okay? Here's the thing. We would be looking at millions of lineages, as I pointed out, in Adam, and millions in Eve. That's why the next question comes down to, okay, how are you going to break up all of these alleles? That's the next question to be answered, and that's where I would point to gene conversion. Okay, remember, more heterozygosity means more effective gene conversion and recombination. And we know the PRDM9 gene, okay, helps with recombination, for example, as I showed those papers. So I hope that was sufficient enough, but good question.
Can I just say something super fast?
Yeah, go ahead.
I still don't understand why the created heterozygosity, you have to put the allele definition like at the base. Because the easiest way to get from one nucleotide to another nucleotide is just a mutation. Recombination rates don't happen nearly fast enough for recombination to explain just all of the different lineages on Earth, right? You have like 1.4 recombination events per chromosome per generation. You're not going to get, tons and tons of haplogroups from that. It just doesn't work like that. Also, I'm pretty sure Argweaver, the program he used, does account for like differing recombination rates. You have to like standardize it by using something back through time. I forget how it's specifically done, but those are just two things.
Yeah, those are some good points. Here's the thing, though, and I read an excerpt from a paper earlier where it shows that just because there's more diversity in a population, it doesn't mean that means that population is necessarily older. Like Africans have more working PRDM9 gene sites, and yet what do they have? Evidence for more recombination versus Europeans. Europeans are highly inbred. What happens with inbreeding? You get more levels of heterozygosity or more levels of homozygosity, which would reduce allelic variability. Now, here's the thing. The PRDM9 gene is well known to regulate, control, and influence recombination through hotspots. So, like I said, the created heterozygosity model would assume what? More heterozygosity, which means more functioning PRDM9 genes and more effective gene conversion. Gene conversion can actually split apart these design variants properly and more effectively. I want to point out one last thing. This is why I say that argument only pretends to assume created heterozygosity, because Dr. Carter and Dr. Sanford make it clear in their papers that these design variants would have been created within helpful and beneficial linkage groups. Like, how silly is it to assume that God creates Adam and Eve? He front loads all of these DNA differences, but then, oops, God accidentally placed them in sections of our DNA that can't recombine or can't work with gene conversion. I mean, that doesn't make any sense. So yeah, more PRDM9 gene sites in the past, less mutation accumulation, more levels of heterozygosity means more rounds of recombination, more effective rounds of gene conversion. So I think it's a plausible answer. I don't expect the evolutionists to tap out on it, but I'm happy with it. I think it fits well.
Okay. I would love to have this conversation with you sometime in the future. Because I definitely disagree, but that's okay.
Listen, at some point, it's just an excuse to have another conversation. But that was going to have the last word. It's his question. I'm not going to let you steal this one, Walker. Nice try.
Yeah. Well, I wasn't trying to steal it. I was just saying I disagree, but go for it.
No. I mean, listen, I'm totally kidding. You guys have been answering each other's, giving comments on each other's questions all night. I'm trying to add some levity to the conversation. Come on,
that's why we pay you the big bucks, Erica. You've been very neutral. Oh, yeah. You've been doing a good job. I didn't even see one negative face expression from you all debate. That's good.
Listen, I was bragging about it in chat. I'm stone faced, baby. You don't know what I'm thinking. You don't know what's going on behind these specs. So I believe that's all the super chats. We have some non-super chat questions, but we do have a lot of them. So I almost tentatively feel like we've been here quite some time. Only if you guys just have absolutely nothing going on and you totally want to answer the questions. But fair warning, most of them are for standing.
Well, let me, of course, I paid them all to ask me questions, so I looked special and important.
Yeah.
We, all four of us, we've been sitting here since 9. That's 3 hours. I'm personally kind of tired. We have answered all the super chats. I'm happy to end it at the 2-hour mark, but I'm kind of tired.
No, I'm
I think
there's my guy.
Yeah, we'll call it then. And we'll just use it as an excuse to come back and have another conversation another time. In which case, if you guys would like, I'm happy to come back and mod again. And I know Praise is absolutely chomping at the bit to come and do another one.
And Praise, you did step up your game eventually when I got a little bit mad at you. You did a great. Praise actually, I think, was the star of the show tonight. So I just want give a round of applause to Praise. Praise, if it wasn't for you, this wouldn't have happened. So.
Listen, I can't operate OBS, so I'm sitting at Praise's mercy when on these kinds of things. So, and I can't pretend like I could do it any better. So in that case, we'll wrap it up. Thank you everyone for being here. I hope everyone stays safe and gets a good night's rest. I know this is for the other individuals who are living in the United States. It's been a very interesting past couple of days, and we just want to make sure you're staying happy, staying healthy, and doing what's best for yourself. In that case, we will end it by saying, let us keep on sifting out the reasonable from the unreasonable. I'm Erica, and thank you for being here tonight.